Our goal for this lesson is to use the law of sines to solve for problems, or to solve problems. So first we have the law of sines. The law of sines says that the sine of angle A over side A, so side A is going to be directly opposite angle A, equals the sine of B over side B equals the sine of C over side C. So our sides are always opposite our angles. The capitals are angles and the lowercase are sides. So this looks like a pretty big equation, but we can break it down. We can use either just these two parts, or we can use just these two, or just these two. You can break it down and set any part equal to the other. Okay, so some useful things that we can use from geometry could be some of our triangles. When we had congruent triangles, we could have triangles that were congruent by three different things. Okay, we had angle, side, angle. Where our triangle was congruent, where the side was included between the angles. We had angle, angle, side. Where we had two angles and the side was not included. And we had side, angle, side, which is also congruent. And there was one that only worked for right triangles. For right triangles, we had hypotenuse leg, where it looked like side-side angle, which we knew only worked for these right triangles. When we have side-side angle, we'll see why this only worked for right triangles, and we're going to use it when using our law of sines. So first we have an example. It says, solve the triangle ABC, where A is 48 degrees, B is 22 degrees, and A equals 5, and we can call that 5 inches. I went ahead and set up the triangle where I had A, we have B and C, and, oops, my bad, B and C. So angle B is 22 degrees, angle A is 48 degrees, and we can use our law of sines to solve for this little b here, this side B. So the way we use our law of sines is we say the sine of B, which is 22 degrees, over side B equals the sine of what we can use what is given, the sine of 48 degrees over 5. So this is using sine of A over side A. We can multiply over, and we have B equals 5 sine of 22 degrees all over sine of 48 degrees. So you don't want to forget your degree signs. Always remember these degree signs. And then to solve for this, we're going to have to put this in the calculator. And you want to make sure your calculator is in degree mode. So you put it in degree mode, and then we can do 5 sine of 22 divided by the sine of 48. And we get 2.520. So our side B is 2.520 inches. So I can go ahead and put that up here. And this is just set up just like we had for solving our triangles. We can solve for the measure of angle C by doing 180 minus our 48 minus our 22 degrees, and we'll get that angle C is 110 degrees. So this is 110 degrees. And then we can use the law of sines again to solve for that remaining side. So since this is an approximation, I'm going to go back to the original side that we use using A. So the sine of A is 48 degrees all over side A, which is 5. And we want to find side C, so we'll do the sine of angle C, which we found to be 110 degrees all over side C. And then we'll have C equals 5 sine of 110 degrees all over the sine of 48 degrees. And we can put that in our calculator and we'll get C equals 6.322 inches. Alright, so we've completely solved for this triangle. We just want to make sure that we're using the correct ratio of sides and angles. So we can note for this one what we were given was angle, angle, side. So this was an angle, angle, side triangle. And we know that they're only going to have one solution. Okay, so for those first, for the angle, side, angle, 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 side, and side, angle, side, we're only going to have one solution for these triangles. Alright, so let's try another example. We want to solve the triangle ABC where A is 30 degrees. Angle A is 30 degrees, side A is 30 meters, and side B is 40 meters. So note this one, we're going to have side, this one is side, side, angle. Alright, so this is the one we knew only worked when doing congruence. The only way it worked was using right triangles with the hypotenuse leg. So this one will become clear later why this only works for that hypotenuse leg. Alright, so to start, we want to use our law of sines to solve for an angle. Okay, so we have angle A and side A, so I'll use the sine of A, which is over A, equals, and I'll solve for B first. Sine of B over B. So we know our sine of A is sine of 30 degrees all over side A is 30 meters. We have the sine, we don't know the angle B yet, but we know side B is 40 meters. So to solve from here, we're going to have that the sine of B equals 40 sine 30 all over 30. Now here we're going to use inverse sine of this value here of 40 sine 30 degrees all over 30. And that's going to equal our B. So when we put this in the calculator, we can do our inverse sine of 40 sine of 30 divided by 30. And we'll get B as 41.810 degrees. So B is 41.810 degrees. So now we can solve for our angle C, and that's going to be 180 minus our 30 minus our 41. Okay, sorry about that, the camera died. So where we left off, I was finding the measure of angle C. So to find the measure of angle C, we're going to take our 180 degrees of the triangle and subtract the 30 degrees and 41.81 degrees to get our last one. And we'll find that angle C is going to be 108.190 degrees. And then we can use this to find our final side. So we have the sine of, and I'm going to go back to angle A since that we know the exact value of. Otherwise, we use stored values in our calculator. And this equals the sine of C, which is 108.190 degrees all over C. And when we solve, we'll get that C equals 57.002 meters. Okay, so now we want to know what happens if B is obtuse, because this is going to be one solution to our triangle, but we want to check for a second solution. So I have this one triangle here. I'm going to use the same values to look at this next triangle, and we're going to talk about what happens when B is obtuse. So same triangle, I just drew it differently so that B is obtuse. We still have the side B is 40, side A is 30, and angle A is 30 degrees. So to make B obtuse, we're going to take 180 degrees, and we're going to subtract off the 41.810 degrees that we found earlier, and we'll get 138.190 degrees. So we're going to look at what happens when B is 138.190 degrees. So the reason we can do this is that sine inverse is restricted from negative pi over 2 to pi over 2. Okay? So if we had our circle here, sine inverse is restricted to this section over here. Okay? So we can't get any obtuse angles like we could over here, because we know that looking at for sine, these 2 points for sine are equal. So we want to figure out how to get this one. So we'll take our 180 and we'll subtract off this angle that we found, which was our 41.81, to get this obtuse angle. Okay? And it'll give us this obtuse angle here. So now we have this obtuse triangle. And we want to check that there's actually two solutions. The way we check that is that when we did this 180 minus 41.810 and got 138.190, it's less than 180. So since this value here, since 138.190 is less than 180 degrees, that means we have two solutions. Okay, so we want to find the second solution. So we had the first solution on the previous slide, now we're going to look at the second solution. So we can find our third angle because we know B is 138.190. I'm going to solve for that. We can find our third angle by taking 180 minus 30 minus 138.19, and we'll get that our angle C is 11.810. So now we can use the law of sines to solve for our third side. So we'll have the sine of 30 degrees over 30, again I'm using the given, equals the sine of angle C, which is now 11.810 all over C. When we solve, we'll get C equals 12.280. Okay, so that is our second solution to our triangle. So therefore, we're going to have two solutions. Now, on a test, if you have a triangle that has two solutions, you must give both solutions, both complete solutions, in order to get this correct. So for the both complete solutions, you would have this here. This is one solution, and then this here is your other solution. So in order to get full credit, you have to put both solutions down. So now we'll have one more example where sometimes there'll only be one triangle. Again, we can see that this triangle is side-side angle, okay? And we have that the measure of angle B is 82 degrees, side B is 17, and side C is 15. We can make these meters to give ourselves some units. And then we can use our law of sines again. So here, we're going to have the sine of 82 degrees all over 17 equals the sine. I want to solve for c first since I have that side, sine of c over 15. So then I'm going to get, using inverse sine, you can plug this into your calculator, you have the inverse sine of 15 sine of 82 degrees all over 17 equals c. And then we'll get c is 60.899 degrees. Now, you can do something similar to solve for side A, and we can solve for angle A as well. So to solve for angle A, we can subtract 180 minus 82 minus 60.899, and you'll get your 10.355. Okay. To solve for side A, we can do the sine of 82 degrees, so you can see it, all over 17 equals sine of 37, oops, sorry, this is 37.101, doing our 180 minus our 82 minus 90. Sine of 37.101 all over A, and we'll get that our A is 10.355 meters. Okay, so that's how we solve for this triangle. But now you always want to check for a second triangle. Always check for a second triangle. Okay, so we can see if C has another value. So we can say C goes to 180 minus 60.899, so that would equal 119.101. Alright, so we have, this would be our new angle for C. And then we can take this and see 180 minus 119.101 minus our given of 82, and that equals negative 21.101 for angle A. This is not possible. So therefore we only have one solution with this triangle. Okay? So this here is going to be your one solution. So now I have one last example. Is, again, this triangle is side-side angle. And we're going to use our law of sines to solve. So we'll have our given, our sine of 36 all over our side 2 equals, and then we have side B, so we'll have the sine of B all over 7. Okay, so to solve, we'll get sine of B equals 7 sine 36 degrees all over 2, and this will give us the sine of B equals, if I put this in the calculator, I'll have 7 sine of 36 divided by 2, and that's 2.057, which is not possible. Okay, because sine of any angle is always going to be between 1 and negative 1. Okay, so therefore for this triangle we have no solution. Okay, so things you want to remember: round to 3 decimals. 2, use stored values. So you don't want to use our rounded values, you want to use your stored values. 3, always check for another triangle. Okay, so that's going to be it for this lesson.